just to start things off, we are looking at a case where demand is given by 70 minus Q. And in the Cournot case, we had two firms, red and blue, that together produces quantity. We have each firm had a marginal cost of 10 that was constant. For thinking of comparing to monopoly, the equivalent there would be that the monopoly has a constant marginal cost of 10. Okay, so we're going to be wanting to draw this to make comparisons. And here the drawing will be not as a drawing of best response functions that we had previously, but instead we're back to price and quantity. So, this kind of diagram would be useful, or this comparison is useful for thinking about, what are the deadweight losses of Cournot competition, for instance, compared to deadweight loss of monopoly, etc. So I want to look at prices and quantities, how much is produced. So we could draw that demand curve. So that's like so. So 70, and this is demand. We could also draw the marginal cost curve, of course. So that's at 10. So yeah, we're writing here marginal cost like that. Okay, so just for comparison, we could look at, if it were a monopoly, what would it do here? Well, it would set its quantity to maximize profits. What are profits? Well, that's price, which depends on quantity, times quantity, minus costs, which are 10Q, and we're disregarding fixed cost here. So differentiating the profits with respect to the quantity, finding the optimal quantity, the profit maximizing quantity. That's the case where the slope of the profit function is equal to 0. Okay, so d pi dq, just multiplying in there and differentiating, is equal to 70 minus 2q. Okay, so differentiating 70q minus q square with respect to q. And this, of course, is marginal revenue, and this was marginal cost. And to find the optimal point, we look at the case where the slope is equal to 0. Okay, so we want to solve for the optimal quantity, and we find that it's 30, and we plug that into the demand function to find that price when quantity is equal to 30 is equal to 40. Okay, so let's draw that. So we have a marginal cost function, or marginal revenue function, sorry, that is twice the slope. So let's write MR here. What's the optimal quantity there? Well, it's 30, and at that quantity of 30, the price is equal to 40. And as you know, in the monopoly chapter, there would be a deadweight loss here. Okay, so we can call this PM, not prime minister, but monopoly price. Okay, we're comparing that then to the Cournot outcome. We solved for that in another example. So let's do that in orange. So there we had that quantity for red was the same as quantity for blue, which was 20. So total quantity Q colon QC, as in Cournot, so QR star plus QB star equals 40. So just adding the two 20s. Two firms each producing 20. How much is marketed? How much bottled water is brought to the market? 40. What's the price then at the Cournot quantity? Well, 70 minus 40 equals to 30. Okay, so we actually, there's no marginal revenue. I mean, there's a marginal revenue for each of the firms, but we're not drawing that here. That would be, we have total quantity here, so that would be funky to draw. Okay, so quantity is 40 and price Cournot is 30. Okay, so this is an important point here. What happens? Well, the Cournot price is lower, quantities are higher, so there's still a deadweight loss, but it's lower than under monopoly. Okay, so competition is driving price down. It's increasing quantities. It's lowering the deadweight loss. So that's a good thing with from a social perspective here in the Cournot equilibrium. There's still a deadweight loss though, so we could see what would if the firm acted as a price taker. It's not, we're not going to go to perfect competition here if we're thinking just one firm, but we could say this is a firm that for one reason might be publicly owned and very well organized, so it wants to maximize social welfare. What would a price-taking firm do? Well, it would set quantities such that price equal to marginal cost, right? So in this case, what's price? Well, 70 minus Q equals to marginal cost. What's marginal cost? That's 10. So Q equals 60 in that case. 60 here, and price equals to, well, we could say it's equal to marginal cost directly, or we could go the roundabout way and actually do the calculation and see that it's 10 here. So, okay, so there's comparing Cournot to monopoly and to perfect competition. There's a deadweight loss, there's an inefficiency. Competition lowers price, increases quantities, but with just two firms, not all the way to the perfectly competitive or to the price-taking outcome. I should also say that there's no no collusion here, in the sense that the firms are not agreeing to anything. They're not having any they're not doing anything illegal, right? They're acting independently, but they're taking account their knowledge of how this market works. So they're, just as in the monopoly is balancing the incentives of the more it produces, in some sense, the more does it sell, but the drawback of that is that it's driving down prices, and the balance of those two effects will give the monopoly quantity. The same kind of logic is true for the Cournot firm, but the difference now is that if it's holding back quantities to hold price up, the competitor is going to be stepping in and reaping some of those gains of that lower quantity. So the incentives for Cournot firms, for an individual Cournot firm to hold back quantity are lower than what they are for monopoly. But the incentives are still there, and that's why we see a Cournot price such that it's between the monopoly and the perfectly competitive price. And as we document later in chapter 10, one of the appealing features of the Cournot equilibrium is that as we're looking, we can look at more firms than two, and as more and more firms are added, the price tends to the price-taking price to the perfectly competitive price. Okay, so yeah, that's it for the comparison.